am Victoria Bowler, a math teacher at West Feliciana High School. This is a 9th grade geometry class, and we're in our triangle congruence unit. Our curriculum we're using is a district-approved, district-made self-curriculum that is focusing on LA standards. And our objective today is just getting the kids to prove and apply theorems involving angles of triangles. Today we are focusing on the exterior angle theorem and on the triangle inequality theorem. They did an activity prior to this where they proved the triangle angle sum theory using an inquiry method where they cut triangles and saw that the three angles formed a straight line so that they should add to equal 180. We're going to work on applying that and on finding and using the other two theorems that I've already mentioned. And in this lesson, what we're really focusing on is creating different experiences for these kids by letting them have an inquiry activity with the triangle inequality theorem using our spaghetti noodles. Go ahead, take out your note packet that we started on Tuesday. It's the one that has the triangles taped to the front of it that we did, the triangle activity we did on the front. We started triangle theorems on Tuesday. So we're in our triangle unit. We're worrying about triangle congruence right now. And our first theorem we wanted to talk about was triangle angle sum theorem. And all that's going to tell you is that my three angles will always add to equal 180. And when we did our little activity for this, all we did was we took three of the same triangles. And what we wanted to do was get it to where we had different angles all meeting at the top. So instead of giving y'all a big formal proof for it, we did this little activity instead. And we see at the top, all three angles, 1, 2, and 3, meet to form a straight line. And what do we know a straight line is equal to in degrees? 180. So we know that when I add all three of those together now, that's going to equal 180 as well. And that's all we did. We didn't get to any application problems, which is what we're going to do today. We're going to set them up together, and then I'm going to get y'all to do them yourselves. For this application problem, I have two different triangles, and I'm asked to find the measures of 1, 2, and 3. So I'm going to do my first triangle, the one on the top, because I only have one angle that I need to solve for here. If I know that these three add to equal 180, how can I set up an equation to solve for angle 1? What you got, Tim?
You could do like 180 equals 61 plus 68 plus x.
So we can make angle 1 equal to x, yeah? And then go ahead and give me x. What will x equal?
Oh, yeah.
151. So 61 plus 68 is?
129.
129 plus x is equal to 180. And when I subtract 129, I get what? I get 51 is equal to x. And that is what my angle 1 is going to equal. And then I have one more angle I need to solve for. I need to solve for angle 3 on the bottom triangle. How can I set that up, Carter?
You add together 90 because it's a right angle. The measure of angle 2, which is 61. You add those two together, and you subtract that from 180, which gets you 29.
Right, so to set it up, I could do that way. I could do 90 plus 61 and then subtract that total number from 180. Or let's go ahead and name angle 3 y and do 90 plus 61 plus y is equal to 180. And then you can get y by itself. Either way is perfectly fine. But if I want to set something up, a type of equation with a variable, we're going to do it just like this. So someone go ahead and do that math and tell me what you're going to get for y.
49.
Good job. Okay, we got a few more we're going to do today, actually. There's a second one on there. Do we see a vocab word we've done in the past?
Bisects.
Bisects. And what does bisects mean?
It splits it.
Into 2 equal halves.
Yeah, it's going to split it into 2 equal halves. So if BC bisects, this is my line that's bisecting it, ACD, what does that mean for angles 2 and angle 3?
They're 45.
They're both 45 degrees because the total angle is 90. So angle 2 and angle 3 are going to be 45 degrees. Okay, Carmen's going to go do angle 1 on the board.
I got angle 4.
And you got angle 4. Let me check your angle 4. Everyone, go ahead and check angle 1. You should have set it up, add 45 and 48. And then subtract that from 180, you get 87 for angle 1. Jaden, go ahead and do angle 4 for me. Okay. Love the clapping, love the clapping. Let's look at this one. What does that look like that we've done in the past? Yeah, it has to do with our transversals, our parallel lines cut by a transversal. I know there's going to be a few different steps and vocab words that might come back up in this case. What you got, Jaden?
Could I explain how to get angle 2?
Yeah, tell me, how do I get angle 2?
Okay, so right, you already got angle 1, which is 73, and then you already got the other angle, which is 49. So you add 73 and 49 to get 122, and then you subtract 122 from 180.
Yeah, so let's go ahead. Let's do angle 2 the way Jaden was describing it. We're going to actually skip the last one. We're starting our next theorem, the exterior angle theorem. What you need to know about this one, it says the measure of an outside exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. Looking at this picture here, they gave me triangle PQR, and we see how PQ at the bottom extends further. It's a ray, it goes all the way out. All this theorem is telling you is that angle 1 plus angle 2 should equal angle 4. This is a 2-column proof. We've done those. It's just been a second. So we're going to walk through this together. They gave me that PQR is a triangle, and that angle 3 and angle 4 are going to be a linear pair. And they want me to prove that angle 1 plus angle 2 is equal to angle 4. So for my first statement, they told me that PQR is a triangle. What's my reason? It's always going to be given if they gave it to me. I should always start off with a given statement. Now my second thing they gave me is that angle 3 and angle 4 are a linear pair. What's my reason for that one? Given. It was also given. It's up there at the top next to given. Now that we have our proof and you know that no matter what exterior angles, my exterior angle theorem is always going to be true, we have a few examples at the bottom. Let's go ahead and look at this first one. If I wanted to set this up to find angle 1, how could I do that? Someone new. What you got, Cade?
76 plus 52 equals angle 1.
Right, I'm going to do 76 plus 52 is equal to angle 1. My two insides should always add to equal my outside angle. What is 76 plus 52? 128 is equal to angle 1. Okay, our last one, we have triangle ABC. So we're bringing back x, we're bringing back our linear equations. Can someone tell me how I would set this one up in order to find x? Francis, what you got?
13x minus 11 plus 4x plus 1 equals 18x minus 15.
Should equal 18x minus 15. And y'all go ahead and solve for x and find me my angle measures. Tyler, go ahead, solve for x. And then Amelia, you're going to find me my angle measures. All three. Perfect. You should have got x equals 5. Go ahead and check your work. Amelia is doing my angle measure. She's been begging me to get to go.
For that one, I just added these two.
You got 75. Perfect. Okay, so we're done with exterior angle theorem. We have one more theorem we've got to do today. We're going to do another little inquiry activity. I told y'all we were doing 2 this week. I'm going to come around and hand you 2 pieces of spaghetti. What I want you to do is break this up into 3 different length pieces. Your goal with this, form one triangle where all 3 sides work, and then try to form one that can't make a triangle. Try to come up with what my theorem might be telling me.
Length of any 2 sides of a triangle must be less than the measure of the third side.
Yeah, so you just add 2 of them, and then if the one that you added is bigger than the other one, then it's not a triangle.
Maybe it's because the top one, it's a straight line, so that would form more than 180 degrees.
Being similar size of the two legs, right? No, that's gonna work. That works. We have to make one that doesn't work. Here.
Why do you?
If you go like that, it doesn't work, which she wants.
I'm just wondering if it's because if one is super short.
Well,
Maybe it's just like.
the connector that connects it at the bottom, whatever it's
What do you
called, this part is always too short.
It wouldn't be able to form a triangle because all the sides have to equal 180 degrees. They can't connect because when the two shorter side lengths connect, they can't stretch far enough to connect to the larger side length.
Perfect triangle. That's a little funky.
So that's a good formal way of saying it.
Distance and greater.
It is right. Like it can't be equal.
It cannot
Okay,
be.
so it's great. So we got it all then.
So, but let's look at your two examples you have down here. If you put the equal to sign,
No, we put 9 as in like it can be 9 because that's it can be 9. That's one of the thoughts.
you didn't want to just put 8 and up.
Yeah, we could have.
I mean, you're good. But if it was 8.1, think about it. Would that work?
Oh,
It would be longer.
You are right.
I've heard some really good discussion about it. What did you notice about the two sides where we couldn't make a triangle? Your not triangle is what y'all were calling it.
Both have to be really short.
They have to be shorter than my third. So let's go ahead and let's look at your definition of your triangle inequality theorem. The length of two sides of your triangle, any two, has to be greater than the measure of that third. Let's do some examples now. I want to determine whether or not these are actually going to form a triangle for me. So for number 1, my three side lengths are 8, 17, and 24. I want to add together 8 plus 17. What do I get with 8 plus 17? 25. And I want to determine, is 25 greater than 24? Yeah, it is. So this will form a triangle. Can y'all go ahead and do that for 2, 3, and 4 on your own? Okay, let's go ahead and talk about these. Number 3, 25 plus 35. What does that equal? A lot more than 12. It equals 60. Is 60 greater than 12? Yes, this is going to form me a triangle. And then my last one, add 28 and 50. What do you get? 78. 78, is that greater than 22? Let's go ahead and check number 4 again. But what if I add two different side lengths? What if I add 28 and 22? What does that equal?
50 and it's equal.
So 50 is actually equal to 50. So in cases like this where you find that two angles are actually equal to each other, that's not going to work. So the last one is a no. And Jack, Sam, will you go around with the trash can so they can throw away their spaghetti noodles? By the end of this lesson, the students were supposed to be able to prove and apply theorems involving triangle angles. And today they worked on being able to solve for the missing measures. But next time I see them, they will be working on actually using these 3 different theorems in proofs and on continuing to work towards solving for both angle and side measures in different triangles where they'll be using all 3 combined. Next time I teach this lesson, I do want to give the students rulers during the triangle inequality activity so that they can measure each piece of spaghetti noodle and they can really see that the side lengths matter when trying to form a triangle and that the 2 shorter pieces need to be longer than that third piece. I think that would really help them solidify that concept. This year, this has been very much a learning experience, and the admin and staff here has been amazing. They have been so supportive, and I love the community that I've been able to form all at West Feliciana.